My name is Alex Prokopik, and this presentation was generated for data visualization class at UMGC for the Unit 4 time series. My topic here is U.S. energy generation solar costs and EV grid demand, with a research question of as solar costs get cheaper and EV adoption increases, is U.S. electricity mix shifting fast enough to support future grid demand? We'll start by looking at energy generation by source starting in 2009. This tree diagram shows the energy generation by source, and its block size represents the amount of energy generation. Over time, we'll see that coal starts to shrink in its dominance, with natural gas overtaking being the primary energy generator around 2015. Another note is that solar and wind start off small, but end up being in the top 6 energy generation sources in 2017 onward. If we take a look deeper at that same data set over a time series, we can look at projected values for these energy sources over the next 6 years. We'll note that natural gas continues to increase, as well as wind and solar, with the potential for solar to double its energy generation in the 6-year period. Additional note here is that coal is also projected to continue its sharp decline through 2030. These values have a moderate confidence in the overall direction and a lower confidence in the exact forecasted values. That could be due to policy, fuel prices, demand growth, and grid constraints that could change the future path. If we look at the cost of energy generation from renewable resources, we can see here over a time series that our current top 2 cheapest energy generation sources are onshore wind and solar photovoltaic, which I'll refer to as solar PV. Interesting note here is that we see that solar PV cut its cost to 1/10 of its price in 2010 in 2024, while onshore wind has taken a little longer to reduce its cost, and in the same time period only cut to about 1/2 of its price. So I want to take a look more deeply at solar cost projections into the future, since that is one of the key dominant players in renewable energy. Solar PV in 2024 had an average cost of about 3 cents per kilowatt hour. And if we look at a 95% confidence range, we could have a solar PV cost of 2.5 cents per kilowatt hour in 2029. Again, this is a moderate confidence in the downward direction with a lower confidence in the exact value in 2029. That has the potential to drop to about 40% of the price by 2029. Key areas that could impact the actual price are future costs due to supply chain, labor, policy changes, and market conditions. Taking a look at EV grid demand, the chart shows the vehicle sales and EV growth over time. EV sales are increasing, especially in the recent years. EV shifts energy demand from gasoline to electricity from the grid. So these EV sales are going to increase the demand on the grid as the years go on. If we take an estimate of 0.3 kilowatt per mile from the average EV and an average driver traveling about 13,500 miles per year, we could estimate a demand of 4,050 kilowatt per hour per EV per year. If we take an average of 3 million EVs added in 2024, that could be an increased demand on the grid of 2,000 million kilowatt hours by 2024, each year added. This grid demand is going to be compounded by increases in household energy use, as well as data centers beyond the adoption of electric vehicles. So what can we say about all this? U.S. electricity mix is continuing to change, and natural gas is overtaking coal, but wind and solar are growing. Solar costs have fallen sharply and are projected to continue to fall. EV adoption is increasing, but electrification also adds grid demand, which could be compounded by these household energy uses and data centers. Falling solar costs support the transition, but renewable energy growth must continue if electrification is going to reduce fossil fuel dependency. My sources for this presentation came from Argonne National Laboratory, Bureau of Transportation Statistics, Federal Highway Administration, Our World in Data, Bureau of Economic Analysis, and U.S. Energy Information Administration. Thank you for your time.